Hi, and welcome back. We are going to cover Chapter 4 today, which is all about carbohydrates. So let me pull up our slides. And so this is Chapter 4. It's carbohydrates. We're going to learn that carbohydrates are broken down into sugar, starches, and fiber. And just before we get started, carbohydrates are one of the areas that are really misunderstood by the public or by the population. And so I kind of want to forget everything you may think you know or know about carbohydrates, and let's just start from the beginning and start with just the basic kind of scientific viewpoint of carbohydrates, and we'll go from there. A lot of people think that carbohydrates will make you fat. That is not the case. In fact, you have to have carbohydrates for energy. Your body will break down carbohydrates ultimately into the sugar called glucose. When you measure your blood sugar or your blood glucose, you're measuring the amount of sugar or glucose in your bloodstream. And you have to have that in your bloodstream for your brain to function. It is a preferred fuel for your muscles as well. So carbohydrates are essential. I think part of the reason carbohydrates have gotten a bad name or have been confused as being fattening is because a lot of times carbohydrate foods, which are going to be things like bread, pasta, rice, fruit, some dairy like milk and yogurt, also things with added sugars like sodas, candy, desserts, those type of things. These are typically the foods that we eat a lot of, and we don't necessarily watch our intake or portion size of. So a lot of people are eating way too many carbohydrates, way more than they need, and they're also not choosing the healthiest sources of the carbohydrate. They're getting it from chips and French fries and sodas and candy and added sugars, rather than eating appropriate amount of carbohydrates and choosing brown rice and an apple and yogurt and that type of thing. We mentioned sources of carbohydrate already. So let's jump in to kind of the basic structure of carbohydrates. Now, I'll go ahead and tell you, you do not have to know the chemical structure of carbohydrates or the different monosaccharides or disaccharides. But we're going to start with, in which you may have heard the term simple sugars and complex sugars or complex carbs. Monosaccharides and disaccharides are what we refer to as our simple sugars or our simple carbohydrates. They are called simple because they are very simple in structure. We'll come back to those in just a second. The polysaccharides are what we refer to as complex carbohydrates because they are more complex in structure, in their chemical makeup and structure. They're much bigger, they're branched, they're long chains, they're much more complex. Let's talk about your monosaccharides, because monosaccharides are the simplest, smallest carbohydrate that you can have. Mono means one, and saccharide means sugar. So it means one sugar. Sugars are not bad. All carbohydrates, whether it is brown rice or a Coca-Cola, ultimately are made up of sugars. Okay? These single sugars called monosaccharides. There are 3 of them. And they're little ring-like structures. You'll see the picture in your book. And there's 3. There's glucose, fructose, and galactose. And these 3 monosaccharides are what essentially all of the carbohydrates, whether they're healthy or we consider them unhealthy, are going to be built upon. Let's talk about glucose. Glucose is what your body is actually able to use and break down for energy. When you eat carbohydrate, ultimately everything is going to be digested and broken down, and the end goal is to get everything broken down and converted to glucose so that it can float in your bloodstream and your muscle cells can pick it up, or the different cells in your body can pick it up and use it for energy. Glucose is also part of every disaccharide, and that'll make more sense in just a second. Fructose. Fructose is the natural sugar that's found in fruit. It is also what makes honey sweet. It's the sweetest of the sugars. So there's fructose. And then galactose. Galactose, you rarely see it occurring alone. But I do want you to know these are your three monosaccharides: glucose, fructose, and galactose. You'll notice, or you may have noticed already, that they all end in OSE. That's going to be your tip-off. If you see something that ends in OSE, that's your tip-off that it is a sugar. Okay, so let's talk about monosaccharides. Here's some pictures of monosaccharides, and again, you don't have to know the structure. This is a picture of several different pictures of glucose, but you'll see it's just a ring-like structure. Okay? And here's the different monosaccharides if you want to see how they differ, but you can see they're all ring-like structures. Okay, so disaccharides are created when you link two monosaccharides together. If two glucose molecules are bonded together, that disaccharide, because it's two units now, two sugars, is referred to as maltose. If a glucose and a fructose molecule are bonded together, that gives you sucrose. And if galactose and glucose are bonded together, that gives you the disaccharide lactose. You'll notice that all of these disaccharides, the one thing they have in common is they all contain at least one glucose. Maltose has two glucose. You'll also notice that they also end in OSE. So again, this is your tip-off. If you see a word that ends in OSE, that it is a sugar. And let's look at the name disaccharides. Di typically means two, and saccharide means sugar, so two sugars. Okay, so these are just simple sugars, and a disaccharide is one that is made up of two sugar molecules. The monosaccharides are linked together or bonded together to create a disaccharide through a chemical process or reaction called condensation. So when you put two monosaccharides together, put two glucose together to create maltose, or you put glucose and fructose together to create sucrose, that is done through a process called condensation. And during digestion, though, we're going to be worried about, or we're more concerned about breaking down the bonds between the sugars. So if you were to break the bond in maltose between the two glucose units, that reaction is referred to as hydrolysis. So you're going to break the bond, and that will break the disaccharide into two monosaccharides. Make sure you know those, you understand those terms. Condensation is when you're putting something together and building something. Hydrolysis is when you're breaking something down and breaking it down into smaller pieces typically. But you'll hear those terms over and over again in the next couple of chapters. And this is an example of maltose. Pretend like, or it looks like it was bonded right there by that red line. And during digestion, you would break that bond, and so you would be left with two single monosaccharides, and in this case, two glucose. Okay, let's move on to polysaccharides. Polysaccharides are your complex carbohydrates. Okay, they are made up of these monosaccharides and disaccharides. So polysaccharides are just longer, more complex chains of these mono and polysaccharides bonded together. That's all it means. They refer to glycogen as a polysaccharide or a complex carb. Glycogen is how your body stores extra glucose in your body. So let's say you eat a really high carbohydrate meal. You've got a lot of glucose floating around in your bloodstream, which you don't need all of it right then. One option that your body has is to take those glucose, those extra ones, and store them, bond them together to create glycogen, and store them in your muscle and liver to save or to use for energy in a few hours. So let's say you don't need all the glucose in your bloodstream right now. You might bond those glucose together, store them as glycogen in your muscles or liver, and then in 2 to 3 hours when you haven't eaten in a while and you don't have much glucose in your bloodstream and you're needing some energy, your body can actually pull that glycogen out of storage and break it down into the individual glucose units and release them into the bloodstream. Starches are what we truly think about as polysaccharides or complex carbohydrates. Starches are the storage form of energy in plants, in vegetables, in fruits, in grains. So it's how plants store their energy. And basically starches are made up of glucose molecules that are linked together in long chains. They may be branched or they may be unbranched. But they are made up of those same mono and disaccharides and linked together. And here's two. You can see glycogen over here. It's very branched. But let's look at the starch over here. Here's two different types of starch. You can see one's kind of a straight line. One is kind of curly and twisty. So they're much more complex, and each of those little blue hexagons is one sugar molecule. So you can see these have hundreds, are made up of hundreds of sugar molecules, each starch is, compared to the monosaccharide that had one and the disaccharide that had two. So this is why it's called a complex carbohydrate, because it's more complex in structure. Okay, another polysaccharide, or complex carb, is dietary fiber. Okay, so the starch was the energy, where the plants stored energy. Fiber is the structural part of plants. It differs from starch. Some fibers you can digest, some you can't. But fiber gives the structure. So think of like a baked potato. Okay? The inside white that you put butter and sour cream on, or mashed to make mashed potatoes, that's the starch. That's where most of the energy is. That's where most of the carbohydrates are. The outside skin that holds the potato together and keeps its form, that's the fiber. It's the structural part. Okay? There are two different types of fiber: soluble fiber and insoluble fiber. Neither fiber can really be digested or broken down. Soluble fibers are fermentable or viscous. They can absorb water. So they absorb some water and they create kind of like a gel-like substance in your GI tract. And they can be digested some by good bacteria in your GI tract. A lot of your fruits and vegetables are really high in soluble fiber. Soluble fiber is also the one that is linked to lowering your cholesterol, your blood cholesterol. And you may have seen that on some food labels or in commercials, like with oatmeal. It'll say eat a bowl of this for a month or 6 weeks and we guarantee your cholesterol will lower by 10 points. It's soluble fiber that does that. The gel that the soluble fiber creates when it's fermented actually can pull out some of the cholesterol in the bloodstream and thereby lower the total cholesterol in the body. Insoluble fibers cannot be digested by bacteria. They don't absorb water, or they don't, but they aren't viscous. They are found in a lot of your grains and vegetables. A lot of fruits or vegetables and grains are kind of a mix of soluble and insoluble, but usually they'll have more of one type of fiber than the other. Insoluble fiber, its kind of purpose is to add bulk to your waste product, to keep things moving, because if there's bulk in your GI tract, that tells your body that something is in there, and it needs to keep things moving and move things through the GI tract. We're not going to worry too much about resistant starches. Okay, now that we know a little bit about the structure of simple carbohydrates and complex carbohydrates, let's talk a little bit about carbohydrate digestion. Your ultimate goal, whether you eat monosaccharides, disaccharides, or starch, is to get that energy from the food. Okay, and so to do that, you're going to have to digest it or break it down. Now, your complex carbohydrates, like your starch, are usually also have fiber in them. They're going to take a lot more digestion. For one, because you've got that fiber in there usually, but also because they are much more complex. So you've got a lot more bonds to break before you can get to those individual monosaccharide units. Monosaccharides and disaccharides, they don't require as much digestion. You don't have the fiber, they aren't packaged with the fiber, and then they just have one, if any, bonds to break. Carbohydrate digestion technically starts in your mouth. When you start chewing, you have saliva that helps you chew up the food. And in the saliva, there is an enzyme called amylase. And it starts to break down starch into smaller polysaccharides, smaller sugar chains. Okay, so it just begins working on breaking down the very beginning stages of breaking down the starch. You'll swallow, and it goes down in the esophagus and into the stomach. In the stomach, there is a lot of stomach acid, as you know, and it will further break down the starch, although most of the carbohydrate digestion does not really take place here. That acid is really trying to work on the proteins, and so the stomach acid does break down, do help with some digestion, but most carbohydrate digestion is going to happen in where it's going to move next with the small intestine. Fiber, one thing that fiber does in the stomach is it slows how quickly the stomach empties. Okay? And you'll see that referred to as gastric emptying. Gastric, if you see the word gastric, that's another word for stomach. So if it slows gastric emptying, it slows how quickly the stomach empties into the small intestine. So if your stomach stays full longer, you're going to feel full longer. So that's why a lot of people say add fiber, add fruits, add vegetables, add whole grains to your meal, because it keeps your stomach full longer. So you can, it's really helpful with dieting so that you feel full longer when you're trying to not eat as many calories. Okay, so the carbohydrates that you're in the process of breaking down will then move on to the small intestine. Most carbohydrate digestion occurs here. And really all carbohydrate absorption is going to occur in the small intestine. So in the small intestine, you have pancreatic amylase. And let me point out that just like sugars ended in OSE, enzymes are always going to end in ASE. So this, you don't know what pancreatic amylase is, but you can look at the last three letters, ASE, so you know it's some type of enzyme. It's probably released by the pancreas, and it's going to help further break down those starch chains. You also have enzymes that are going to target specific disaccharides to break those bonds in the disaccharides. Maltase is going to work specifically on maltose and break that unit between the two sugars. Sucrase on sucrose, lactase on lactose. And again, notice they all end in ASE, so that is your tip-off. But as by the end of the small intestine, you want to have everything broken down into monosaccharides, because that's when absorption can occur. And absorption will take place in the small intestine through the walls of the small intestine. Okay, so anything that you can use for energy that's been digested is absorbed. So anything left is essentially going to be waste product, or your fibers. So your fibers will move on to the large intestine. Fibers will absorb some water. They'll help soften stool. They'll add bulk to your waste product, which tells your body that you need to go to the bathroom. And that's a very quick look at carbohydrate digestion. This is a good breakdown that you may want to go back in your book and look at. Kind of takes you step by step what happens to the monosaccharides and disaccharides and starch and fiber. Okay, I mentioned that absorption of the carbohydrates happens in the small intestine through the small intestine walls. This is either going to happen through active transport or facilitated diffusion, but basically the sugars are absorbed through the small intestinal walls into the bloodstream. We're not going to go into detail about active transport and the facilitated diffusion. I just want you to know they're absorbed through the intestinal walls into the bloodstream. They will first go to the liver, and remember, glucose is what your body needs for energy. So any fructose and galactose will be converted to glucose by the liver. And so after that, you've got glucose floating around in your bloodstream that's available for your body to use. Okay, lactose intolerance is a common issue that you see, and it's because people lack lactase enzyme, or maybe they don't make enough of the lactase enzyme. And so if they don't have enough lactase, they can't break down the lactose that they eat. And lactose is going to be like your milk sugars. That disaccharide is found in a lot of your dairy products, your milk products. It's what gives milk like it's kind of a naturally sweet, slightly sweet taste. Your lactase activity in your body is highest right after birth, which makes sense since you're essentially living on milk or formula as an infant, as a newborn. And then slowly as you age, it's going to decline. So a lot of times you see elderly individuals or older individuals who may have never had any issues eating ice cream or cheese or milk, and then as they've gotten older, they've started to have issues. And symptoms that you see with not being able to fully digest the lactose, or that's essentially lactose intolerance, is going to be bloating, abdominal discomfort, diarrhea, gas. It kind of varies person to person. There are certain ethnicities where it is more prevalent. It's highest in Southeast Asians and Native North Americans. things you can do, the diet changes that you can make. You don't want to totally cut out dairy, but you want to have small servings of it and slowly kind of increase your consumption. You want to mix your dairy, like your milk or your cheese. Make sure you're eating it with other foods from other food groups. A lot of times if you eat it with other foods, your body can tolerate it better and break it down better. Spread your dairy throughout the day. Don't have a big old 2 cups of milk in the morning, or, that's not what your body needs. It needs a little bit. It needs it spread out over the day. A lot of times, or sometimes, people who are lactose intolerant can tolerate acidophilus milk, or yogurt, or kefir. And these are fermented and have good bacteria, and it's actually the good bacteria in them that help break down the lactose, so people who are lactose intolerant don't have the symptoms. You can use enzymes, like over-the-counter lactase, which is sold as Lactaid. Some of those work better for some more than others. So you can kind of tinker with your diet. It's going to be kind of unique or individualized to each person, what you need to do. And you can see right here your dairy is the highest source of lactose. Okay, we're going to briefly touch on carbohydrate metabolism, or how the body uses carbohydrates. Now remember, when you eat carbohydrates, whether they are simple carbohydrates, simple sugars, or complex, they are ultimately going to be broken down into monosaccharides and then converted to glucose. So glucose is your key player when it comes to your body using your carbohydrates for energy. So you've got all this glucose that's coming to your bloodstream now after you eat and digest and absorb a meal with carbohydrate in it. You've got several different options. One of your options is you can store glucose as glycogen. It's through a condensation reaction where you put the glucose units together and bond them together to form glycogen, and you can store these glycogen units in the liver or muscle. There's limited glycogen storage, so once you've maxed out your glycogen stores, you can't store anymore. The other option is you can use the glucose in your bloodstream to fuel your body's cells. And this is what your body will typically do first with the glucose in the bloodstream when you eat and digest and absorb carbohydrates. Is your cells, your muscle cells, your nerve cells, your brain cells. They can pick up the glucose and break it down for energy. Now, if you can also, another thing you can do with the glucose in the bloodstream is you can actually, let me back up. One thing, you can see how essential glucose is for the cells to have energy. If you are not eating carbohydrates, or you're eating an extremely low carbohydrate diet, your body has to have a survival mechanism for how it will get carbohydrate. So when it's in trouble and it doesn't have glucose, it can actually make glucose from protein. This is not something your body likes to do, and you really don't want to use your protein. You don't want to waste it to make glucose. But it can take an amino acid, which is what proteins are made up of, and convert it to glucose. And this process where you convert protein to glucose is called gluconeogenesis. You really don't want your body to do this because, again, like I said, you want your protein to be used to build and repair the body or to build muscle and that type of thing. So this is not a good thing. You'll see the term protein sparing. You want to spare your protein. You don't want to use your protein or you don't want to have to use it to get glucose. So you'll see the term protein sparing, and that protein sparing just means taking in an adequate amount of carbohydrate so that you don't break down protein for energy. You can also, if your body still doesn't have carbohydrates or glucose, a source of glucose, either through starvation or eating very low carbs or no carbohydrates, it can get some glucose from fat fragments. And your body will actually take some fat fragments and convert them to what they call ketone bodies. Ketone bodies can be broken down and you can get a little bit of glucose from them, which your body's kind of in survival mode because it needs glucose to keep the brain and body cells running. So it's not a good thing. When you make ketone bodies, you are said to be in a state of ketosis, which disrupts the body's acid balance base. Your body becomes very acidic. In fact, sometimes if someone's in ketosis, their breath may actually smell like they've been drinking alcohol, and it's just because of the acidity in their body from breaking down the ketone bodies. They say the minimum amount needed so that you don't break down protein and you prevent ketosis is 50 to 100 grams of carbohydrate per day. So that's the minimum. Now, we've been talking about not having enough glucose, but what if you have too much glucose? Your cells that need energy have gotten the glucose they need. You've stored some glucose as glycogen, but you still have extra glucose in your bloodstream. Your body can then take that glucose and convert it or store it as fat. Your body has unlimited fat storage or lipid storage. That's another name for fats. And so this is part of the reason why American population keeps getting bigger and bigger. We can store unlimited amounts of fat on our body. And so when we take in excess carbohydrates or excess calories day after day, we're going to store it as fat. Okay. Blood glucose, same thing as blood sugar. You'll hear those terms used interchangeably. But let's talk about how your body works to maintain your blood glucose level. Your body wants to keep a steady supply of glucose in the bloodstream. It doesn't want it to get too low. It doesn't want it to get too high. And your body can kind of control this by the food that you eat or releasing that glucose into the bloodstream. It can also control it by storing glucose as glycogen, so it takes glucose out of the bloodstream and lowers it. But then also when your blood glucose gets low, your body can break that glycogen down to help bring up the blood glucose. There are two hormones, though, or really three, but two main ones that help control or keep your blood glucose in normal parameters. The one you've probably heard of is insulin, and insulin is really key. What insulin does is when you have glucose floating in your bloodstream and your cells need that glucose for energy, insulin is what allows that glucose into the cells so the cells can break it down. Insulin is kind of like the key that unlocks the cell door. So the glucose can get into the cell can break that glucose down. When that glucose goes inside of the cell, you've removed that glucose from the bloodstream, which lowers the overall level of the blood glucose. So insulin lowers your blood glucose level. It helps to lower it. Okay? Glucagon does the opposite of insulin. Glucagon is released when your blood sugar, let's say it's been a while since you've eaten, when your blood glucose starts to get kind of low. And glucagon kind of says, hey, the blood sugar is getting kind of low. I don't know when they're going to eat again. And so it will signal glycogen to be broken down and released, which will release glucose into the bloodstream, which helps give you a little energy until you eat next time. It also helps to keep you from your blood glucose getting too low and you blacking out or that type of thing. So glucagon helps to raise your blood glucose. Insulin lowers your blood glucose, glucagon raises. Now, epinephrine also raises your blood glucose, but epinephrine is what we know as the fight or flight hormone. Let's say you're really tired, but then something scares you and you take off running. And you just take off running, you don't even know where the energy comes from. That is from the epinephrine. You got scared, you ran. That's a hormone that comes out to provide that energy or that glucose to you very quickly. And it comes out during times of stress. So let's kind of look through this chart. When you eat, the food that you eat or the carbohydrates that you eat are going to be digested and absorbed into the bloodstream. And so when you absorb that glucose into the bloodstream, that causes your blood glucose level to rise. When your blood glucose rises, that tells the pancreas, hey, the blood glucose is getting kind of high. And so that signals the pancreas to release insulin. And so the insulin will be released into the bloodstream, and that will allow the cells that need glucose for energy to use that glucose. So when the cells use it for energy, that takes the glucose out of the bloodstream, thereby lowering the blood glucose level some. Your body can also, if it still has more glucose than it needs, your body, insulin helps to store that glucose as glycogen in your livers and muscles. So when you store it as glycogen in your liver and muscles, that also removes glucose from your bloodstream. So that's another way your body helps to lower the overall blood glucose level. And then if there's blood glucose left over that you don't really need, that's above normal parameters, then your body can stimulate the conversion of the excess glucose into fat, and you'll store that extra glucose as fat. Now let's look at, let's say it's been a while since you've eaten. So your blood glucose level in your body is starting to get lower, okay? Starting to get hungry, maybe a little tired, maybe getting low blood sugar. This lower blood glucose level will stimulate the pancreas to release glucagon. Now, so let's say it's been 3-4 hours since you've eaten breakfast, you're sitting in class. Your body has to still have energy or glucose so you can keep going. So your body will stimulate the pancreas to release glucagon. Glucagon is released, and glucagon tells the liver cells to break down the glycogen. When you break that down, then it releases glucose into the bloodstream. And so when you release that glucose into the bloodstream, that raises the overall blood glucose level. So that it doesn't get too low, and so that you still have energy until you get that next meal or snack. The best way to help your blood sugar stay within normal range is to eat balanced, regular meals. Eating regular snacks and regular meals, and meals that are balanced, are really the best way to help your body regulate your blood glucose. And you may be able to tell that if you eat something that has a lot of this really high carbohydrate or has a lot of added sugar. You may kind of tell that, a lot of people will feel really hungry like an hour later, and that's because their blood glucose has dropped really low. It went high really quick when you had that sudden, all that added sugar, go into your bloodstream, and now it's dropped really low. Okay, so diabetes. Diabetes is abnormally high blood glucose levels. And this is caused because either the insulin in a person's body is ineffective, or they don't have enough, or they don't have any at all. And so there's two different types of diabetes, and they're caused, they're due to two different reasons. Type 1 is what you may hear referred to as juvenile onset diabetes. Typically, you see it diagnosed in the childhood years, sometimes as late as teenage years, and sometimes even as late as early to mid-20s. But typically, it's going to be in the childhood years. Type 1 is where your pancreas just stops making insulin. They think it may be related to an autoimmune condition. There's a lot of research looking at that. But basically, your pancreas stops making insulin. So you have no more insulin in your body. So you have to start providing your body with insulin from an outside source, which means insulin injections. You have to have insulin injections several times a day to help regulate your blood glucose, because you don't have the insulin in the pancreas to help do it now. Type 2 diabetes. This is become the much more common one. You see it typically in as people get older, but you're seeing it now some in people in their 20s and 30s, and occasionally now even in children. This one is linked to inactivity, excessive calorie intake, and it's basically your body can still make insulin, but your fat cells are resistant to it. So even though your body is releasing insulin from the pancreas, those cells don't want to use it, so they aren't taking up the glucose from the bloodstream and using it. So because of that, the blood glucose level stays high. So this is treated in several ways. One, through diet and exercise. They may also give oral medications, and then if oral medications and diet aren't enough, they may also do injections as well. Type 2 diabetes is the type, not that you can totally reverse it, but it's the most reversible. A lot of people can, if they work really hard and eat a healthy diet and lose weight, some are able to get to the point where they can get off their medication and regulate their blood glucose through diet and exercise. But you want to do that early on, or as soon as you get diagnosed, or before, or once your doctor says, hey, your blood sugar is running kind of high. Hypoglycemia is low blood sugar. And this is fairly common. Most everyone gets this from time to time. Some people have it much more common. They're much more sensitive to carbohydrate intake and changes in the carbohydrate intake. And so one way you can know if you're very sensitive to low blood sugar or hypoglycemia, things you can do, eat regular balanced meals, avoid foods with added sugars, candy, desserts, sodas, that type of thing, and have some protein, make your carbohydrates complex carbohydrates. Those type of things can help with preventing hypoglycemia. Glycemic response. This refers to how quickly glucose is absorbed. So basically, you eat a banana. What glycemic response is referring to is after you eat that banana, how long it takes for your body to break the carbohydrate down in the banana, convert it to glucose, or absorb it and convert it to glucose, and then cause a change in your blood glucose level. Your blood glucose level is going to rise and then return to normal. The quicker you see a glycemic response, usually the simpler the carbohydrate. You really don't want a quick glycemic response. You want a longer glycemic response, and that's what you get from a lot of complex carbohydrates. They release their glucose slowly because they're much more complex. And so because you have a slower glycemic response with your complex carbs, they fuel you or give you energy for a lot longer, keep you full for a lot longer. With simple carbohydrates like a soda or dessert or that kind of thing, requires no real digestion or not much, and so it causes a very quick glycemic response. That's not necessarily what you want. So a low glycemic response is what you want, or that's what I was referring to as a longer glycemic response. A high or a quick glycemic response is what you don't want. There's a glycemic index where they actually classify foods. I was thinking we had a slide on that, but they actually classified foods. That's in your book where they show kind of how different foods affect the potential for raising your blood glucose. This may be helpful some just in making general choices, but what's going to change is when you eat a meal and you combine several different types of carbohydrates, proteins, fat, that's going to change the glycemic response some. So glycemic index might be useful for helping pick out healthier foods. You want the ones that have the lower or longer glycemic response. But that's about all it's useful for. Okay, health effects of sugars. Now, let's talk here about what I mean by sugars. We've been talking about sugars pretty much all class, because that's essentially what your simple carbohydrates are, your monosaccharides and disaccharides. Sugars, like your monosaccharides and disaccharides that are found in fruit, that are found in milk, that are found naturally occurring in foods, are what you typically hear referred to as natural sugars. Those sugars are not bad for you, and these are not the sugars that we're referring to here. What we're referring to here are what are known as added sugars. And added sugars are the ones, or when you take sugar, honey, brown sugar, sugar, syrup, corn syrup, brown sugar, molasses, you'll see the list in your book, and add it to a food that doesn't naturally have it. So let's say you take an apple and you cook it and you make applesauce, and then you add some brown sugar to it. Well, that applesauce would naturally have that brown sugar in it. That brown sugar is added sugar. And when you add sugar to foods, it's really only adding calories. It's not adding any nutrients. And there are a lot of foods in our food supply today that have added sugars in them. And they think Americans' high intake of added sugars is what has led to a lot of the obesity and other chronic diseases that we see today. If you eat a diet high in added sugars, well, you're probably not getting all the nutrients you need because you're probably not eating all the fruits, all the vegetables, all the low-fat dairy, the lean protein, the beans, the whole grains that you should be. Instead, you're eating the chips and the French fries and the sodas and the candy and that kind of thing, which are essentially kind of empty. They just have calories in them. Let's see. Just because a substance is natural, like honey, does not mean it is necessarily healthy or healthier. Honey, when you add it to a food to sweeten it, is an added sugar. And there's nothing really that makes honey that much healthier or different than adding brown sugar to food or white sugar to food. The USDA Food Guide recommends that you can have some added sugars in your diet, but that you use those as part of your discretionary calories, that little bit of extra calories you have at the end of the day, that was talked about in Chapter 2. But most people today are taking in way more than that. The dietary reference intakes also suggests or recommends that not more than 25% of your day's total nutrition or total calories should come from added sugars. And I think that's kind of high. Most people are getting that or more right now because of all the drinks and foods that are common in our food supply and always around us that have added sugars in them. There are health effects caused by sugars. We mentioned obesity. Obesity puts you at higher risk for things like type 2 diabetes, for heart disease, for heart attacks. An excess of added sugar can also put you at risk for tooth decay or dental cavities or caries. The bacteria, the sugar that's left on your teeth, the bacteria can actually ferment it, which can erode the enamel and cause some tooth decay. So these are the recommended intakes. And remember, these are added sugars that we're talking about. And most of the negative things you see in the media about sugar, they're referring to added sugars. Okay, there's artificial sweeteners. And these are sweeteners that have little to no calories. They really don't provide any nutrients either. They were designed originally for people with diabetes, so they could have something sweet or sweeten their drink or food without it having an effect on their blood sugar. There's several different types now, and it's kind of funny. They're known by color mostly. Stevia is the newest one. It's usually in the green packaging. Truvia is a brand name of one type of stevia. Stevia is thought to probably be the healthiest right now, just because it is taken from plant leaves, so it's fairly natural compared to a lot of the others like the pink one, Sweet and Low, or NutraSweet, or Equal, the blue one, that are essentially chemicals that are made in a lab and happen to be sweet. There's a lot we don't know about the long-term effect of these. In fact, we really have no research on the long-term effect of different artificial sweeteners and taking them in daily and any kind of long-term effect. The FDA would not clear them for usage unless they had passed tests and not demonstrated any kind of imminent health threat, but we don't really have any long-term research, and so that's what you kind of want to remember. I think a little bit's okay, and I tend to try to choose stevia or Splenda, which is sucralose when possible, over the blue or pink packets. Okay, so let's talk about some good health effects of starch and fiber. And starch, remember, is referring to your complex carbohydrates. Your whole grains are going to be good sources of complex carbohydrates, of starch and fiber. Your fruits and vegetables are also going to have that soluble fiber and some of the complex carbohydrates. So taking in complex carbohydrates and plenty of soluble fiber does several things. It helps protect you from heart disease and stroke, or it improves your heart disease risk, which would include heart attack, stroke, high blood pressure. Because for several reasons, but the soluble fiber actually helps lower your blood cholesterol level. Also, there's the thought that taking in the fiber maybe displaces some fat you might be eating if you weren't eating the fiber. The soluble fiber and the whole grains can help reduce the risk of type 2 diabetes. Your high fiber foods can help reduce your risk of type 2 diabetes. Your GI health. Taking in plenty of high fiber foods as well as adequate fluids helps keep things moving regularly through your GI tract and out of your body. I tell people what's left in that large intestine is kind of like the trash in your kitchen. You don't want it sitting there for several days or a week. You want it to get on out. You want to take it on out. And so by having fiber, that signals to your body, hey, there's something in the large intestine that we need to get rid of. So it helps. That's how the insoluble fiber in particular helps keep you regular and keep things moving. And that has been linked to lowering the risk of colon cancer, which is that your colon is the same thing as the large intestine. Fiber and your whole grains can help with weight management. The fiber and these complex carbs are going to take longer to digest. They're going to make you feel full, so it can be easier to eat less calories to help you lose weight. I mentioned the colon cancer. You can read more about that in your book. You can take in too much fiber. This is very, very rare, but you can take in too much fiber, and it will actually can cause a blockage in your GI tract or an obstruction. It can also block some nutrient absorption. But the bigger problem in America is not taking in enough fiber. Here's a list of sources of, this is soluble fiber up here, and then insoluble fiber down here, and then health benefits. And then here are the recommendations for carbohydrate and fiber. And so the AMDR, 45 to 65% of your energy each day, or your calories each day, should be from carbohydrate. They set an RDA for carbohydrate, but really this is going to be very unique to each person. The fiber, there are several different recommendations. You can see there's one, 11.5 grams per 1,000 calories. There's another, it says 14 grams per 1,000 calories. Most people eat around 2,000 calories. So I typically say around 25 grams of fiber per day is what you need to aim for. But it's going to depend on your particular diet. But most people are not getting enough fiber in their diets. And here's some suggestions on how to increase fiber in your different food groups. This is in your book as well, so I'll let you read through that. And then there are recommendations on how to make better food choices in your book. And again, I'll let you read through that. Protein foods that are like meat, chicken, poultry, those have little to no carbohydrate. Now your protein foods that are not from animals, like beans, like soy, those are going to have some carbohydrate in them. And then they talk about the food label list in your book. This is actually about to change in the coming year. Right now they list the total carbohydrates, the starch, the fiber, and the sugars. But right now the sugars is just the total number of sugars in a serving, which includes both natural and added. And as I mentioned earlier, natural are okay. What we really need to be concerned about are the added ones. So what the FDA recently announced is that they are going to be updating the food label where added sugars is broken out on the food label, so you can see how much is added, because that's what you really want to avoid and watch out for. It's key to look at the food labels. You really have to look closely here's 3 different breads. And the other thing I'd say is you can't necessarily go by the name of the bread. Okay? The only thing that natural doesn't really mean anything. Multigrain doesn't really mean anything. Multifiber doesn't mean anything. The word that does mean something when it comes to whole grains and bread products is the word whole. You want to see the word whole. And you want that first ingredient in the ingredient list to be a whole grain. So you can see in this first one, first ingredient is unbromated, stone ground, 100% whole wheat flour. That means the primary ingredient is 100% whole wheat flour. Now if you look over here at the natural wheat bread, the first ingredient is unbleached enriched wheat flour. This is not whole wheat flour. This is not whole grain bread. And again, if you look over here, this has some whole grains in it. It's got barley in it and cracked wheat and oats and brown rice. But see, those are at the very bottom of the list. Your first ingredient is what's most prominent in it. And you can see that first ingredient is your enriched wheat flour, which is not a whole grain flour. You want to see the word whole wheat flour in there. Okay, that wraps up chapter 4. Read through the highlight 4. I think it'll have some interesting information for you about carbohydrates and kind of different misconceptions we have and what's correct and what's not. Read through the chapter and the study guides, and make sure you understand everything before taking the quiz.